What's up coders, this is Coding Cleverly, and today we're going to be making a tree data structure. Before making a tree data structure, I want to show you that I have two files existing here in my VS Code. One is tree_node.java, the other is tree.java. So a tree_node.java will be all of those nodes inside of that tree. So here's a simple example of a tree data structure that I just created right now. The top thing over here is called the root node. So this is a visual implementation of a tree. Now trees are wonderful data structures that can model real-life hierarchical information, including organizational charts, genealogical trees, computer file systems, which are in our computer system, HTML elements on a web page, which are also known as the document object model, DOM, and then state diagrams. There's so much in computer science and so much more. The applications are endless. Now second, we have to look at the composition of a tree. A tree is composed of tree nodes. Now these balls over here you can see are tree nodes. Now there is a root tree node, and that's the top thing over here. And then we have the children tree node, which may or may not be parent nodes themselves. It's an optional portion here. First, we're going to focus on building the tree node data structure. So we're going to look at creating or try to build one of these tree nodes first. And then after we're done creating that data structure, we'll move on to creating our entire tree data structure. So the first data structure that we're going to implement is the tree node data structure. And then once we're done with that, we're going to map it out with our entire tree data structure. Now let's head on to our programming and let's get started. So over here, we're going to go in the tree_node.java file and let's get some things done. Now, a tree node contains three different things: data, a list of children, where each child is itself a tree node, and then the optional part here is a pointer to a parent tree node. So if there exists a parent, then we could have a pointer that points to the parent tree node. Some implementations do this, but I'm not going to cover this in this video. All right, so the first thing that we have to bring up here is that we have a public class tree node. Now, like I told you, we actually need to create a data for our tree node. So I'm going to say public. I'm going to use the object type, which is in Java. So the object, and then we're going to say data here. Now we're going to create an array list to store all of our children's. So we have a tree node. For instance, let's look back to the diagram. Here we have the root node, and the root node also has links to these two kids, right? We have 1 and 2, so 2 children. So we have the data here. Suppose we have a data 2, and we also have the list to these two things. So we have the data, suppose is over here is 3, and the data over here is suppose it's 4. Now what you want to do is you want to also store these inside that structure. To do that, we could create an array list and we'll store that inside that public, and then we're going to say array list, and then we're going to have the angle bracket here, and we're going to say tree node type, because it's going to be the same thing as a tree node, and this is going to be called as children. Now you might get this red underline here because we don't have it imported here, so we're just going to get the java.util.array list. So there you go, we got this one, and now that red underline is gone. Now we want to create a constructor for this, so we can say public, and we say tree node, and inside of this we could pass in the data we want to add. So object data, and we could assign that. So this dot data, which is over there on the top, those are, so these things over here, these two things are called instance variables. Now we're going to assign those with our input parameter. So we're going to assign our class variable with our parameter, this dot children, and we're going to assign the array list here. So we're going to say new array list, and then we just assign it with the type of tree node, and we need these round brackets at the end just to create an initialization. Done with this process. So now let's go to the add child method. Now add child could be implemented in two different ways. One, we could add the child just by putting the tree node child in there, or we could add a child by just telling the data, and then that would create it. So right now you'll understand it when I'm going to type the code. So here we're going to create a public, and we're going to say void, and we're going to say add child, and here we're going to add in the tree node type child, And to add this here is pretty simple. We want this dot children, and then we have the add method, which is in the array list, and just add in the child that was passed in as the input parameter. Pretty simple. And now we're going to create another add child method, but this one is going to be a little different. This one will be not tree node child, but we're going to have the object here, object type, and for this object type we'll have child data. And over here, when we want to add this thing, first we're going to have to create the child here. So we're going to say tree node, we're going to say child, because we know that childs are tree nodes, so we have to instantiate it here, new tree node, and then we have the child data that was going to be passed in. So we're actually using that constructor that we created up on the top, and then when we want to add that, we just add it through that. So perfect, we have our add child methods done. So remove methods are also going to be in two different ways. One is by removing it using a tree node child, and the other one is going to be used by object child data. But in case of this one, which is the tree node, will explicitly delete just the single one instance of the entire tree data structure. But for child data, you could have similar data for more than one. So if you have 4 over here and you have a 4 over here, now if you want to delete all of the nodes that contain 4, you could use this method over here, which I'm going to create. I mean, the later method what I'm going to create, which is going to use the child data, and that would remove all of the tree nodes that contain a data value of 4. So first let's create the top one, which is just getting the add child and just deleting. This is pretty easy, so let's start with the easy one. And let's say, so we're going to say public void, and then we have remove child, and here we're going to have the tree node, and we have the child to remove. There you go. So the first thing here is we're going to check if the list is empty or not. If it is, then we just got to return. These are some preconditions that we need to follow. So if this dot children list, so each tree node will have a children list. So if I say this dot children list, the current children list dot is empty, it's a Boolean method. If it returns true, we're just going to simply return and exit out from this method. Now the other case is else if, and this dot children, if that list contains the child node we're looking for, or maybe the child to remove that we're looking for, then we just want to remove it, and that's pretty simple. Here we just could remove it like this dot children, and we say dot remove, and then we have the object. So for that we just have child to remove, and we could just return from here. The other case is that if we don't find that inside of that current list, we're gonna have to iterate throughout. So this is where you gotta really focus here. Suppose we were here and we wanted to remove, let's say, this one over here at the bottom, and we start from the top, right? So we looked at these the list. So the list had only these two elements, 4 and let's say 3, but we want to remove this one that has 5, right? Now we're looking through the tree node instance, right? So we can't find it here, so now we have to use a recursive implementation that would now call the children of this, all right? And if it doesn't find it from here, then it will call the children from this. So we want to do something like that. The recursive implementation is going to be in here. So I'm going to use a for each loop. It's just like a for loop, but it's a little more convenient. So here we're going to use tree node, and we say child. So for every child inside of the list, which was the children list, right? So it's talking about the current one, which was on the top. So we say child dot, and now we're gonna call the remove child for each of the these tree nodes. So each of the children that were inside of the current node, or let's say in this case it was the tree root node, now that all of those children will also call the remove child method, and what they're gonna pass in will be child to remove that one yet you passed in. So that will be passed in, and it's just going to be a recursive call. Now let's go with the last one, which was the remove child with data parameter. So to do this, we're going to have, first of all, we're going to say public, and we say void, and we say remove child, and we want to remove that. We could use the object now instead of the instance of that tree node. We're going to use the object and we're going to say data. And over here we're going to say the first condition is the same as the top one. So I say if this dot children dot is empty, and if it is, just return. Now we're gonna actually go and not just look in just one single instance over here. So I want to remove the nodes, the tree nodes that have the data value 4. So that would remove this one, it would remove this one, it would remove this one as well. And we want to try to get this implementation done. So let's go back to our code and let's see how we do it. So we use a for each loop again, and we go recursive call, like you guessed it, because we want to go and explore the whole tree. To do that, recursion is one of the best solutions. So tree node, and we have child, and we have tree node child, and we have this dot children. Now over here we have for every child in this dot children list, right? So we want to check first. We want to check if the child data value is equal to the data that we passed in as an input argument, right? So if it is, then it really got easy for us, and we could just remove that child, right? You could use that removeChild method and just pass in the data, and then after that we return. So once it's done with that, we just return at the end. And all the other cases here are pretty much the same thing here. So after this, we're going to create another parallel for loop here, but not nested, parallel here. We're going to say tree node, and we're going to say child, and we're going to say for every child in this dot children. So the first case here is just a for each loop that would go and check for that child, and if it exists, it has that same data, it removes it, and also actually recursively calls it with the same data and checks for more instances in that same children list, right? But in case if it doesn't exist in that current list, we want to go in the next list. Suppose we have the root and we have just these two elements. So we have the root over here, and we just have these two elements, 1 and 2, and we couldn't find it here. So now we want to recursively call to the second. Over here we want to call these children right here. So this guy is the parent now, and we want to call these. So for every child in this dot children, now we want to call that recursive call. So we say child dot remove child, and we just pass in the data, and that's pretty much it. Now that we're done with this, let's go ahead and go to the tree data structure. For the tree class, we have the public class tree, and we have a public static void main string args, right? Now we're gonna have the things that we need for this tree. The first thing that is very important is a root. So we say public, and we say tree node, and then we have that as root. Now remember that this data structure tree will be using this to incorporate stuff inside here, and we're just going to use the root. So we're just going to get the root, and from there we could like print the entire tree and show the different representations of how it could be printed using depth first search and breadth first search. We're all going to get all of that done. So first of all, let's just get the public tree node root, and we also want the constructor here. So public, and we say tree, and here we want the constructor. So we say tree node, and then we have the root, and we just pass it in. So class variable root, and we say that equal to the root that was passed in as an input parameter, like that. We want to create a print method that could give some kind of visually appealing representation of our tree. So to do this, I'm going to create this method over here. So it's called public void print, and we're actually calling another print method here, and we're passing in the root here, and we're also passing in the level. So the first input value would be the tree node, and the second one will be the level. So public, and we say void, and let's say print, and now we're going to create tree node, and we're going to say current, which is the current node, and also the level of where it's existing right now. So this is just going to make my representation a little better. So I'm just going to say level marks, and I'm just going to leave it as a null string right now. So not a null string, but an empty string. And for this, I'm just going to say for, and I'm going to say int I is equal to 0, I is less than the level, and then we have the I plus plus, and over here we could have the level marks, and we have plus equal to the hyphens here, and there you go. So we're almost there. So after that, we have the system dot out dot print ln, and over here we could have the level, let's say the level marks, and we have plus current dot data. And we also want a for each loop because we want to try to implement everything recursive calling again. So tree node child, and for each loop we'll have current dot children array list, and over here we could just say print method recursively, and we could type in the child, and we could also put in the level but incremented with 1. We just say like that, and we're done with this. So now we are done with our print method. It will just pass in the 0 for here, and then after that we'll call for here. So it's going to start with the root. The level is 0. The level marks will be something like that. This won't run because 0 is less than 0, so that doesn't exist. So it's just going to print out the first root value. Level marks will be nothing here as well. It's just going to be an empty string. So it's just going to print out the current.data. After that, we're going to traverse it. So all the children array list inside of that tree in the root, right? So inside of that tree root, whatever the children are, one at a time, we're going to use the child, and we're going to try to print them out. So child level plus 1, it's going to add in level. So now we could also access this for loop, and that would just make this these two hyphens come, so that we could know that these are the children and sub children and all that. We're creating a tree root over here. We say tree root new tree node, and we pass in the value. So I'm gonna pass in p additional one. So I'm just gonna create some 5, I guess. So 5 over here. So I'm gonna say tree, and I'm gonna say tree. So I'm gonna create the tree now, new tree, and we're gonna pass in the tree root. So that is the tree root over there. Just pass it in, and now our structure got it. So now we could print it. So we say tree.print, and let's print it and see how this works. So let's go here, tree. All right, so we have p over here. Wow, that's strange. Why isn't the other ones printed out? Because they're not linked to each other. Tree root dot add child, and we have the child one. So we say child one. Similar to that, we have, but these are two linked. We want child one dot add child, and we want the child grandchild one. So, and for the other case, we want the 2 and the 2 over here. So tree root will add in the child 1 and child 2. Child 1 will add in the grandchild 1, and the child 2 would add. So now that these are linked, now you'll see that complete structure. So I'm just going to recompile, and then after that we're going to run. So you can see over here we have p, and then we have a. Since p had 2 children, was a and r, and the subchildren over here was t, and this guy's children was y. So this is how it's appearing right now because of this implementation. Now we're going to create breadthFirstTraversal and depthFirstTraversal. So first, let's get the depthFirstTraversal done. So let's just create the code first, and then after that I'm going to explain what I'm doing here. depthFirstTraversal, and here we have the tree node, and we have the current. And over here we could say system.out.println current.data, and then we have plus, and we have this. So it's just a space. We're not going to do println, we're going to do print, because we want them in a single line. I also want to use the recursive process here to check all of the values out the tree nodes. So we say tree node, and we have child in the children. So we say this dot children. There you go. And in this case, it's not this, so it's going to be the current, since the current was passed in on the top. Now here we're just going to add in the following. We're going to say depthFirstTraversal, and we're going to pass in the child. So it's just going to go like that. Okay, so let's see how this works. It's going to look at my root node first. So the current thing will be the root. Over here where I did current, that's going to be the root. It's going to print that value, and then after that it's going to go in a depthFirstTraversal recursive call. It's going to get the children, and it's going to go to the first child, and it's going to call depthFirstTraversal traversal there, and then from there it's going to go and print that out, and also going to get printed in the first child. So what's going to happen here is that first of all this will be printed, then it will go here, and this will be printed because there's two children, right? So it will just go with the first one, and this will be printed, and then after that we'll go to the children and see the first one. So then this will be printed. So you go back one step here and you see if there's any other children remaining. There is 5, so we just print this one out. And then once we're done with this children, when you go back, we go back one more step and check it for the other children, which is over here. And then we print this guy over here because this is the first children over there. And then after that we go back one step, and then we see that there is one more child over here, so we just print that out. System.out.println and say depthFirstTraversal. We can say tree.depthFirstTraversal. It should be over here. There you go. And the current should be the tree root. So tree root. Alright, so you'll see it. You can see the depthFirstTraversal was PAT and then R and Y, because these had 2 children and the first child was this one, right? So it went and got the other, so it printed this one, it printed this one, this was the first child. Then we had only one child here, so they printed back, went T and then went back, and they saw that they had one other child over here, so printed the R and then went to get the other child. So it came like this, pattery. Awesome. And breadthFirstTraversal, BREADTH, first, and then we have TRAVERSAL. And over here we're gonna type in the following. So we have the tree node current, and we could say that as the root. Pretty simple. And then after that we're actually gonna use a queue here. So QUEUE. We have a queue of tree nodes. So I don't have 2 things here. I don't have a queue and I don't have a linked list. So these are built in, and I could just quick fix here, and I could say import queue. This is gonna import that, and for this linked list, quick fix, and I say import linked list. Now you can see over here on the top we have import java.util.linklist, and we have import java.util.queue. So these are just built in Java, and we're using those. Let's just keep adding stuff here, and then once we're done, I'm gonna be explaining how this is gonna be working. Now all we gotta do is we're gonna have to add things to our queue. So queue.add, and we have to add the current node. Now let's suppose that the current is the root node, and then we have a while loop. So we say while the queue is not empty. So we say queue is empty, and we can say not empty like that. All right, so this portion here was like I said, was while the queue is not empty, because we added the root node over here, and now we're asking if the queue is not empty. We want the current, and we can say queueue.poll. So POLL is a method that would give us the current value, or the first thing in the queue. It will just take it out, and it says over here that the poll method retrieves and removes the head of this queue, or returns null if the queue is empty. It's gonna return the head, and for this case it would return the root, and that would be our current. And we're gonna have the current data, which is the root data, and we also have a space here. And one thing I forgot to say is that it's not println, because we're having it in a single line, so it's just gonna be print, system.out.print. Now we want a queue.all, so we have to add all of the children of the current root inside of it. So current.children. All of the children that were for the root will now be added inside of this. So queue.all will add all the elements in a specified collection in this collection. So while the queue is not empty, you're gonna get the head of the element, put in the current, and that will remove it. Then from there you could get the data, and then also whatever the children were, you're just gonna add them in the queue. That's gonna take them out one by one and also print out their values. And you'll see the breadthFirstTraversal implemented here. So I'm just gonna copy this line over here. So this line should be over here. So let me say like that. And I'm just gonna say over here as breadthFirst. So BREADTH, breadthFirstTraversal. Also, we need a \n here. So I'm just gonna have, and you'll know why, because actually these are just printing in a line, and after that we need to have a \n for just better format. Okay, before running this code, I want to explain how this is working. Breadth-first-search doesn't work like depth-first-search. Depth-first-search, we saw that it works, gets the root, and then it goes and checks the children for the first one, and if it does, it will go over here, and then it will check its children, and it will look for the first one, and then it will print that. So print, go back, right? And then we'll check if they have any other children. It does, so it goes to the next one, the most next one, and then after that print it, go back, and then go back, and then we'll check if it has any other children. Yep, it has. So, and then prints this, and then it checks for the first one. Yep, it is. Print it there, go back, and check for any, print, and then go back, go back. That's how depthFirstTraversal works. But in breadthFirstTraversal, we're gonna go like this. So the root, and then after that, we'll go to the children, and we're gonna print all of the children. So this level will be printed, and then entirely we'll have this one printed. So this level will be printed after that. So this is a little more intuitive way, and you'll see how this is gonna be appearing. Over here was depthFirstTraversal, but I have to change it to breadthFirstTraversal. And since we have this, that should not require us to give any input parameters because it already checks by itself for the root. So let's go back here and compile and then run. So over here we have depthFirstTraversal, which was like that, just like the simple implementation here. But in case of breadthFirstTraversal, we have party. Woohoo, now we can party because we got both of these cleared. Hope we see you guys in the next one. Peace out. Come on, let's go.